Howdy and good day, fellers. It's good to be with you. I am probably the most excited I've ever been for a math lesson yet this year because we finally get to graph in slope-intercept form. We have used slope-intercept form to identify a slope and a y-intercept. We've talked about slope-intercept form. I told you it's going to be one of the three, I think I said three, most important equations that I'm going to teach you. And today we get to see why. Okay. So for starters, let's just remind ourselves, slope-intercept form is y equals mx plus b. Okay. And the reason why we like this so much when graphing an equation is because it very clearly identifies the slope, m, and the y-intercept, b, of that graph. Okay, so here are three steps that you can use to graph any linear equation. Step one, write the equation in slope-intercept form. Which again here is y equals mx plus b. Okay, you'll notice that the objective does say I can graph an equation in slope-intercept or standard form. So if the equation is given to you in standard form, which if you look at the second page, there are like 6 of them, then your first step is to write that equation in slope-intercept form. So it's a good thing that you paid very close attention in PO23 or CO23 and PO24, so you have that how to convert back and forth, okay, from standard to slope-intercept. So step one, write the equation in slope-intercept form. Step two, once it's in slope-intercept form, you're going to plot the y-intercept, okay, which is that b variable in slope-intercept form. So step one, or step two here, but when you actually go to graph it, you're going to plot that y-intercept, which is that b variable in slope-intercept form. Since it's the y-intercept, it'll always be on the y-axis. So your first point when you graph an equation here is going to be on that vertical axis, okay? That y-axis, because it's the y-intercept. Once you've got that point, from the y-intercept, use the slope, which is that m variable, to find a second point. Okay? So once you've got that y-intercept plotted, from that point, sometimes kids like to go back to the origin, back to where the two axes cross, 0, 0. No, from that y-intercept point, use the slope to find yourself a second point. And because you learn how to connect the dots when you were in kindergarten, okay, you only need 2 points in order to graph that linear function. All right. So let's practice here. Let's go to the first one. That's all the lesson is, really. It's just, you know, it's real slick once you kind of get the hang of it here. But let's look at the first one, graphing y equals 1/2 x plus 3. Okay. Below this, or above it actually, I'm going to write y equals mx plus b, just because I'm a beginner here. Okay, got to keep track of what's what, where my m and the b are and everything. So this is in slope-intercept form, so I can skip step one of the 3 steps we wrote up above there and go straight to step 2, which is plot that y-intercept point. So I look for my b, I see it as a positive 3. That represents the point 0, positive 3, that y-intercept point of positive 3. So I'm going to go to positive 3 on my y-axis and plot that point. Okay, 0, 3. Now from that point, I look at my slope, which is positive 1 over 2. That's my m variable there, positive 1 over 2. And remember what that slope tells us. The slope tells us how the line moves across the coordinate plane. It gives us the vertical change compared to the horizontal change. So a slope of positive 1 over positive 2 means I'm going up 1. Looks like UPL, UPL. I'm going to be going up 1 and over 2. Okay, up 1 over 2. And when we say over, we use that word because as a fraction, sometimes you can realize like 1 over 2, 1 half, 1 over 2. But the direction that will always be going is to the right. Okay, so from that y-intercept point, I'm going up 1. I'll do it in a different color so we can follow along here. Up 1 over 2. There's another point. Okay, that was fun. You don't have to do it again, but if you want a straighter line, which I really struggle with drawing straight lines here, I can go up 1 over 2 again, and I've got yet another point. Up 1 over 2 again, I've got another point. You can see that all these points that I'm making here fall in a straight line. Up 1 over 2, I've got yet another point. Okay, and then you connect these with a nice straight line. Ooh, that was pretty good, actually. And there we have it. Okay, we've graphed that equation, y equals 1/2 x plus 3. And the beauty of this is, I went all the way out to here. This point here looks like it's at 8, 7. If I plug in 8, 7 into my original equation, 8 for x, 7 for y, if that point's in the right spot, it's going to work, right? So our original equation was y equals 1/2 x plus 3. I'm going to plug in 7 for y, 8 for x. And does 7 equal half of 8 plus 3? Well, half of 8 is 4. 4 plus 3 is 7. 7 does equal 7. Okay. Let's look at the third one. The third one, y equals -4/3 x minus 1. Y equals -4/3 x minus 1. This is also written in slope-intercept form. You're welcome. Okay, so I don't have to do any conversion. I can go straight to plotting my y-intercept point, which is at -1. That refers to the point 0, -1. Remember, that sign belongs to it. That sign matters. Okay. So 0, -1, plot that point, -1 on the y-axis there. And from that point, my slope is a -4/3. Now remember, that negative sign does not mean that we've got a -4 over a -3, because a negative divided by a negative is actually a positive. Right? So only one of those numbers is negative, and typically we're going to stick that negative sign with the numerator. So you want to think about that as -4 over 3, which means that in kind of more verbal terms, we'll be going down, because it's negative, down 4 over 3. And again, that over direction is to the right. So if your slope is positive, like it was in the first one, positive 1/2, up 1, right 2. If it's negative, then it's down and right. Okay, down and right. But you're always going to the right there, because that's the direction you read a graph, right? Left to right. So from that y-intercept point, a slope of -4/3, down 4 over 3. Again, I'll do a different color here. 1, 2, 3, down 4. Right 3, there's my next point. That's all you need, right? You can make a line with those 2 points there, but just for funsies, down 1, 2, 3, 4 over 1, 2, 3. Make a third point. Again, notice how they all fall in a nice straight line. So we connect them, and there we've graphed the equation y equals -4/3 x minus 1. Okay, let's pick an ordered pair to test here. We'll use that one in the middle. Looks like that is at 3, -5. 3, -5. So we go back up to our equation. We plug in -5. I'll do it over here. Y equals 4/3 x minus 1. Plug in -5 for y. 3 for x. Okay. Well, -4/3 times 3, as we saw kind of in PO24, multiplying -4/3 times 3, those are going to cancel out. So we have -5 equals -4 minus 1, which by golly, that's true. -4 minus 1 is -5. So that ordered pair works. It makes the equation true. And it should work because it's on the line. If we picked an ordered pair somewhere out in space, tested it, one right there, that's not on the line, it's not going to work. All right, let's look at another one here. Let's do y equals x plus 2. So I can scroll down correctly here. Y equals x plus 2. Equations like this tend to throw kids off because they look at this and say, well, where's my slope? Right? Where's my slope? Here's my y equals mx plus b. Where's the m? Okay. Well, remember that m is that coefficient to x. And we've talked about this before with the equations. It's not written, but what's that coefficient to x? It's that 1. Okay, it's that 1. So our slope is essentially 1 over 1 because we think about it, that's like a giant plus sign. Because we think about it as a fraction, coefficient of 1 over 1. Okay, it's not written, but that's going to be our slope. So we start with our b, since it's already in slope-intercept form, that's positive 2. There's the ordered pair 0, 2. So we go ahead and plot that point. And then from that point, we're going up 1 over 1. A slope of positive 1 over 1 means we're going up 1 over 1, which again is to the right. So from our y-intercept, I'm not going to use a different color for this because it's pretty short, pretty easy. Up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1, right? Look at that go, okay? Connecting with the line. Ooh, that was not good. Connecting with the line, and there you have the graph of y equals x plus 2. Let's pick an ordered pair to test. We'll do that one. That ordered pair looks to be 4, 6. Okay, so y equals x plus 2. Plug in 6 for y. 4 for x, and yes, 6 does equal 4 plus 2. It works. I said before that if we pick an ordered pair that's not on the line, it's out in space, it's not going to work in the equation. Let's do that here since our equation is relatively simple. This is the ordered pair -8, 6. And if I plug in -8, 6 into this equation, y equals x plus 2, plug in 6 for y, -8 for x. -8 plus 2 is -6. 6 does not equal -6, right? And it shouldn't because that ordered pair is not on the line. Okay, so it just further proves that ordered pairs on the line will work, and those that aren't on the line won't work. Let's look at some equations that we first must convert to slope-intercept form. Those are always fun. Okay, so down here we've got 6 of them. We'll start with the first one there. 2x minus 3y equals 9. So this actually goes back more to CO23 than PO24. We're given an equation in standard form. We're going to write it in slope-intercept form. So I'll do my work down below here, just so I got a little more space. 2x minus 3y equals 9. So remember our process for this. Okay, we essentially want to get the y variable by itself to put it into slope-intercept form. So using opposite operations, I'm going to start by subtracting 2x from both sides. Cancel it out on the left side. That leaves me with that negative 3y. And on the right side, I can't combine 9 and negative 2x because they're not like terms. Knowing I'm getting in a slope-intercept form, I want my x term before my constant. So I'm going to write it as negative 2x and then positive 9. If you need a review on this part, go back to CO23. Okay, that's where we talked about it. We had the quizzes on it. Okay. Now I'm going to divide everything by my coefficient to y to get y by itself. And so I've got, I'll just kind of write it below here. Y is by itself, y equals negative 2 divided by negative 3. That doesn't work out evenly, but again, we don't care. Slope is a fraction. We just simplify it. Negative 2 divided by negative 3 is equal to positive 2 over positive 3. Those negative signs cancel out. Then my x, and then positive 9 divided by negative 3. Heart, I have heart math too, is a negative 3. Positive 9 divided by negative 3 is a negative 3. So here we have it. Y equals 2/3 x minus 3 is this equation in slope-intercept form. And now we can go ahead and graph it. What's my y-intercept? I'm assuming you all said negative 3. So I'm going to plot that point first. What's my slope? Again, assuming you all said positive 2/3 means we are going up 2 and over 3, which that over is to the right. So from that y-intercept point, I'm going up 2 over 3. This time I will use a different color. Up 2 over 3. If I want to do it again, up 2 over 3, right? I'll make my points here now. And there is, oops, my graph. Okay. What other one should we do? Let's do the last one, since you always ask for the last one here. Negative 7x plus 8y equals 0. Seeing that it's in standard form, I know that I must first write it in slope-intercept form. Okay. Give myself plenty of room here. Right? So negative 7x plus 8y equals 0. As anytime I go from standard form to slope-intercept, I'm going to start by moving my x term to the other side using opposite operations. So in this case, I'm adding 7x. Negative 7 plus 7 is 0. Cancel out there. Along with 8y equals 7x plus nothing. 7x plus 0. Okay. Now, to get my y variable by itself, I'm going to divide everything by 8. And if you don't like the whole heart thing, because you don't like to admit that you really do heart algebra, you can just write, divide by 8, kind of like this. Just make sure that you are doing it to everything on that right side. Okay. On the left side, 8 divided by 8 is 1. That cancels out. So y is by itself. 7 divided by 8 doesn't work out evenly. Don't care. It's just the fraction 7/8. My x. And then 0 divided by 8 is still going to be 0. So in slope-intercept form, that equation is y equals 7/8 x plus 0. And that's the equation that I'm going to be graphing. Y equals 7/8 x plus 0. My b, my y-intercept, is actually, in this case, that plus 0 is the order pair 0, 0. It's at the origin. Okay? I always thought they looked kind of like an owl, that 0, 0. Woo, woo. Okay? Anyway, 0, 0. Right? From that point, my slope of 7/8 means I'm going up 7, because it's positive, over 8. And again, that over always means to the right. So from this point, which happens to be at the origin here, up 7. 1, 2, 3, 4, 5, 6, 7. Over 8. 1, 2, 3, 4, 5, 6, 7, 8. There's my point. And there's my perfect line connecting them. Okay, but there you have it. So if the equation is given to you in slope-intercept form, you've got the y-intercept, plot that point. You've got the slope, use it to move from the y-intercept to find that second point. If your equation is written in standard form, first convert to slope-intercept form, and again, you can look back at CO23, and then from there, use the B, use the M, and get your points. So how the quiz is going to work, there are some concepts where Google Quizzes, just the format doesn't quite match up perfectly. And this is one of those times here. So what I'm going to do is I'm going to give you the graph, and you need to select which equation that graph belongs to. So you are going to graph all the equations on both pages of PO25, and then if you see, for example, a picture on the Google quiz of this graph, I'll have 4 or 5 equations there for you. You're going to look at this page, find the picture that matches, and you'll say, oh, the equation of this is negative 7x plus 8y equals 0. So all of your options, all of your equation options will be equations from this page. But instead of me giving you an equation and graphing it on the quiz, because that's very difficult to do, I'm going to give you the graph as kind of the question, and then you look back at your work on PO25, match the graph with one that you have, and then the equation that goes along with it is going to be the one that you select. Okay? So it's going to be kind of Jeopardy style here, where I'm going to give you the answer, you match it to what you have, and then you select the original equation that graph would come from. Again, you do need to retake the quiz until you get 100%. I think that's working pretty well. Thank you for your honesty and how many times you are taking the quiz. It's not that if it takes you more times to get 100%, I'm going to dock you points. It's a barometer for me to see, how well are people getting this? Is most of the class getting it all in the first try? Are most of them taking 2 tries to do it? If the whole class is saying, yeah, it took me, 5 times, then that tells me that, okay, there's something that we have to kind of work through here and go over a second time. So please be honest. If it is taking you, 2, 3, 4, 5, more than 5 times, mark that each time you go back to edit, because it gives me data, and I love data. All right, enough yapping. Time for you to start graphing, and then go over to the Google quiz and complete that. Make sure you get 100%. That's how you math. Don't forget to like and subscribe, and of course, have a terrific Wednesday.